Okay, so we're going to look at two-dimensional distance, which is the distance on the coordinate plane. We looked at one-dimensional distance, which is the number line. Now we're going to look at the coordinate plane. So I have a picture drawn for you. This is your distance formula. The distance equals the square root of the difference of the x-coordinates, there's that word again, difference, subtraction, squared, plus the difference of the y-coordinates, squared, and then the square root of that. So I'm going to find the distance using the distance formula, and then I'm going to show you another method we can use where the distance formula actually comes from. So let's find PQ first. So I want to find PQ. I'm going to use my distance formula. Now what I always do is I rewrite the distance formula. I write my formula and then I substitute around. And the reason I do that is so that I don't miss negatives and get negatives confused, because signs are the big part of the issue when people are using the distance formula. So let's look on our graph. The distance from P to Q. Okay, point P. My x-coordinate is -3, so that's going to be -3. And my x-coordinate for Q is 3. Now I've just made this x2 and this x1, or vice versa. So what that means is when I plug in my y-coordinates, I have to match the same order. So when I look at my y-coordinates, since this went with x2, that's got to go first also. So that'll be -3 and -1. So now I have y2 and y1, so those match. Now I'm ready to solve this. So as I go through, the distance equals, I've got -3 minus 3. That becomes -6. Always keep your parentheses. Then I've got -3 minus negative. That becomes a positive there. So that's going to be a positive. So -3 plus 1, which is -2 squared. Okay. Now I'm going to square the 6, the -6. It's in parentheses. So -6 times -6 is positive 36. And -2 times -2 is positive 4. And then for my last step, 36 plus 4 is 40. So I've got the square root of 40. Now you can use your calculator to get a decimal. When you do the square root of 40, it's going to be 6 point something, okay? So that's basically what we're going to use. Or you can break it down into the square roots using simplifying square roots. So if I have the square root of 40, I'm going to make my factor tree. So I'm going to come over here. I'm going to make my factor tree with 40. I've got 4 and 10. And 10 is 2 and 5. Okay? 4 is a perfect square. And if you want to, you can break it down into 2 and 2. But you look for prime numbers and perfect squares. So I can rewrite this as the square root of 4 times the square root of 2 times 5, which is 10. There are no pairs. So the square root of 4 is 2. And then I'm left with square root of 10 because that one doesn't have any perfect squares. And we're going to spend some more time on simplifying radicals at a later point. But that's just to kind of give you an idea of how to do it. So let's look at number 2 now. Number 2, we're going to find the distance from Q to R. So now I want to find this distance here. What's the length of that segment from Q to R? So once again, I'm going to start my distance formula. And I'm going to write the distance formula out get it set up, and now I'm ready to plug in. So let's look at our two values. All right, we're going from Q to R. Q, let's say I use Q first. Q is 3, R is -1. So I have 3 and -1. Those are my two x coordinates. Since I use the 3 first for the x's, I have to use the -1 first for the y's. So I've got -1 minus positive 4. And from here, I'm just going to complete the process like I did on the previous one. It's just math. Minus a negative right here becomes a positive, so 3 plus 1 is 4, so that's 4 squared. Negative 1 minus 4 gives you negative 5. Then I'm going to keep squaring, so 4 squared is 16. And negative 5 squared is 25. Notice when we square these, whether they're positive or negative, they become positive, because when you square it, it's a negative times a negative, which is a positive. So that, in turn, is going to give us the square root of 41. So we have to figure out now, let's do this factor tree. We're going to try to factor 41 and see if there's any way we can factor that out. And if you look at 41, there's really nothing that we can divide into 41. There are no real factors of 41. It's actually a prime number, which means it can't be broken down any further like this one could, where we have a perfect square in there. So square root of 41 will then be your final answer. That is the length. And again, that's going to be a little over 6.